Every single month, you're writing a check you didn't plan for. Gas, oil change, brake pads, insurance that went up again without explanation. And somewhere in the back of your mind, there's always that number, the one you don't say out loud. The total amount this car has cost you over the years. Not the sticker price, the real price. The one that includes every single trip to the service bay, every gallon of $4.50 premium, every surprise repair that showed up right after the warranty expired. Here's what that number looks like for the average American man over 55. $93,000 over 10 years. Not to own the car, just to keep it running. Today, I'm breaking down 3 engineering decisions Tesla is making right now for 2026. Decisions that could flip that equation completely. And I'll tell you straight, one of those 3 comes with a risk that most channels won't mention. I will. Before we go further, Tesla has not officially announced the Model 2 by name. Everything here is drawn from leaked engineering documents, supply chain reports, and patent filings. Don't send a deposit to anyone. I'm not selling you anything. Let's get into it.
The money pit nobody talks about. Let me paint you a picture. You're 67 years old. You paid off the house. You did everything right. Social Security comes in, maybe a pension on top of that, and by all accounts, you should feel financially stable. But then the car needs new rotors. Then the AC compressor. Then the transmission starts slipping, and suddenly you're staring at a $3,200 repair bill on a vehicle that's only worth $8,000. That's not bad luck. That's the math of owning a gasoline car past 100,000 miles. An internal combustion engine has more than 2,000 moving parts. Every single one is a potential failure point. Every single one is a line item at your dealership's service center. And here's the thing most people never say out loud. The system is designed this way, not as a conspiracy, just as a business model. Dealerships make 49 cents of every profit dollar in their service bays, not on the sales floor. Oil companies need you at the pump. Every month you keep your gas car, someone profits from its complexity. You've been patient. You've been loyal to your vehicles, and what you've gotten in return is a treadmill of costs that doesn't stop until you stop driving. Here's where 2026 changes the story and why it matters more to you than to anyone in their 30s. When you're 35, a surprise $800 repair is annoying. When you're 68 and living on a fixed income, that same $800 is 2 weeks of groceries. The stakes are completely different. The margin for financial error is thinner, and the decision you make about your next vehicle, possibly your last vehicle, carries more weight than any car decision you've made before. So let's talk about what Tesla is actually building and what it could mean for your wallet, your independence, and your peace of mind.
Engineering shift number 1. The battery that could outlive your mortgage. The number 1 fear I hear from men your age about electric vehicles is the battery, and it's a legitimate fear. You've watched phone batteries die after 2 years. You've read the horror stories about EV owners facing $12,000 battery replacement bills. You're not wrong to ask the question. Here's what's actually happening in 2026, and I'll be clear about what's confirmed versus what's still in the realm of strong possibility. What we know for certain, Tesla is building the Model 2 around LFP battery chemistry, lithium iron phosphate. This is not the same battery that's in your neighbor's iPhone. LFP cells are chemically more stable, significantly less prone to thermal runaway, and, this is the part that matters, you can charge them to 100% every single night without degrading the cells. Standard lithium-ion batteries, the kind in most EVs on the road today, lose capacity faster when you charge them full repeatedly. LFP doesn't have that problem. Verified, documented, already running in Tesla vehicles overseas. What the supply chain data strongly suggests, the Model 2's battery pack is being designed as a structural floor, meaning the battery itself becomes the load-bearing base of the vehicle. This isn't just clever engineering for its own sake. It eliminates 200 pounds of separate chassis components, which means less weight, less rolling resistance, and more real-world range out of the same amount of electricity. What's possible but not confirmed, cycle life ratings in the range of 3,000 to 5,000 full charges before meaningful capacity loss. At one charge per day, that's 8 to 13 years of daily driving before the battery drops below 80% capacity. Some internal projections suggest this architecture could sustain usable performance well past 200,000 miles, but I won't give you a number I can't stand behind with documentation. Here's what this means in plain English for someone who's 65 today. If the engineering holds up as designed, this could genuinely be the last car you ever need to buy. Not because it's cheap, because it's built to last as long as you need it to. And if something does go wrong with the battery after the warranty period, current LFP pack replacement costs are running $3,200 to $4,000 compared to $5,500 to $7,000 for a gas engine and transmission replacement. The worst-case scenario for this car is still better than the average scenario for the one sitting in your driveway right now.
Engineering shift number 2. Unboxed manufacturing and what it actually costs to fix. This is the part most channels skip. I'm not going to skip it. Tesla's 2026 manufacturing strategy centers on what they call unboxed assembly, a process where large sections of the vehicle are cast as single solid pieces rather than welded together from dozens of smaller stampings. The rear floor, which normally involves 70 to 90 separate metal components joined by thousands of weld points, becomes one continuous aluminum casting produced in about 90 seconds by a 9,000-ton press. Think about what that means for long-term reliability. Weld points are where rust starts. They're where rattles develop after 80,000 miles. They're where structural fatigue begins. A single-piece casting eliminates nearly all of that. No welds means no weak points. No bolts means no bolts coming loose after years on rough pavement. It's the same principle that made smartphones more durable than flip phones. Fewer moving parts, fewer failure modes. Here's the real-world benefit for you. Tesla is projecting 45,000 to 50,000 newton meters of torsional stiffness for this chassis. That's the measurement of how much the frame resists twisting. For context, that's roughly double what you'd find in a Honda Civic or Toyota Corolla. A stiffer frame means doors that open and close cleanly at 150,000 miles, windows that seal properly in year 15, a car that doesn't develop the structural creaks and shudders that make older vehicles feel their age. Now here's the part I promised not to skip. If you're in a significant accident, not a fender bender, but a real collision at highway speeds, and the primary cast section is damaged, you can't cut out a section and weld in a patch the way a traditional body shop would. The aluminum casting loses structural integrity once cracked. The entire module has to be replaced. At a Tesla service center, that repair can run $5,000 to $6,500. Some insurance carriers have already started pricing this risk into premiums for Tesla vehicles, increases of 8 to 14% in some markets. This is not a reason not to buy the car. It is a reason to have an honest conversation with your insurance agent before you do. If you drive fewer than 10,000 miles a year, mostly local roads with a clean record, the statistical likelihood of that catastrophic repair ever affecting you is very low. If you're regularly on busy interstates in high-traffic markets, it's a real number you should factor in. For the majority of men your age, driving the way men your age actually drive, cautiously, deliberately, fewer total miles, the unboxed manufacturing story is overwhelmingly positive. Less complexity,
fewer places for problems to start, a vehicle that ages more gracefully than anything with 30,000 individual parts ever could.
Engineering shift number 3. Vision-only safety and the return of real buttons. I want to tell you about a man named Robert. Robert is 68 years old, retired Air Force, lives outside San Antonio. He bought a 2024 luxury sedan, I won't name the brand, and sold it 6 months later. Not because it wasn't a good car, because he couldn't figure out how to turn off the lane departure warning without navigating through 4 separate touchscreen menus. Every time he started the car, the system reset. He was spending real mental energy, the kind of energy that should be on the road, fighting with the interface. That's not Robert's fault. That's a design failure. And it's the design failure Tesla says they're correcting with the Model 2. Here's what the engineering documents and interface leaks are pointing toward: a physical button philosophy for all primary controls. Temperature up, temperature down, physical buttons. Defrost, physical button. Hazard lights, large, obvious, physical button. The touchscreen stays for navigation and secondary functions, but the things you reach for while you're moving at speed, the things your hand needs to find without your eyes leaving the road, those are going back to where you can feel them. At 70 miles per hour, taking your eyes off the road for 2 seconds covers more than 200 feet of highway. That's longer than most gaps between vehicles in normal traffic. The difference between a physical control you find by feel and a touchscreen menu you have to look at is not a matter of preference, it's a matter of physics. The vision-only safety system is where this gets genuinely impressive, and I want to be careful to separate what's proven from what's projected. Tesla's current FSD hardware runs entirely on camera input, 12 high-resolution cameras providing 360-degree coverage with no blind spots, no radar to calibrate, no ultrasonic sensors to replace at $400 per corner. The system reads the road the way a good driver reads the road, through pattern recognition built from billions of real-world miles. In the 2025 holiday update, Tesla's neural network logged 0 phantom braking incidents across 180,000 kilometers of logged testing in construction zones, poor weather, and heavy traffic. For you, this means one specific thing: fewer service visits for sensor calibration and replacement. Every radar recalibration on a competing vehicle runs $180 to $400. Every ultrasonic sensor replacement is $250 to $550. The vision-only system has one failure mode: a dirty camera lens, which you can clean yourself with the same cloth you use on your glasses. Now, let's talk about full self-driving honestly, because this is where a lot of channels oversell and a lot of viewers get burned. FSD, as it exists today, is Level 2 driver assistance. That means your hands stay on the wheel, your attention stays on the road, you are responsible for the vehicle at all times. What FSD does is reduce the cognitive load of driving. It handles the throttle and braking and stop-and-go traffic. It maintains lane position on the highway. It alerts you before you drift. Think of it the way airline pilots think of autopilot. It flies the plane during the cruise, so the pilot arrives at the destination less fatigued. Nobody calls that a failure. That's smart design. What FSD does not do and won't do in 2026 is drive you to the doctor while you read the newspaper in the back seat. Anyone who tells you otherwise is selling you something. What it does do is give a 68-year-old 2 hours of interstate driving assistance that leaves him arriving sharper, less tense, and more in control than if he'd managed every mile himself. For someone whose reaction time has naturally slowed, not because of any failing, just because of time, that assistance is worth something real. The real question: does any of this actually help you? Let me bring this back to the only question that matters. Not, is this car technically impressive? It is. Not, is this the future of automotive engineering? It probably is. The question is, Does this help you, specifically you, a man over 65 on a fixed income, keep your money, keep your independence, and keep your dignity for the rest of your driving life? Here's how I'd answer that honestly, without selling you anything. The battery technology helps you keep your money if it performs as designed. 10 years of avoided oil changes, transmission services, brake jobs, and fuel costs adds up to somewhere between $25,000 and $35,000 in real savings compared to a comparable gas vehicle. That's a real number based on real maintenance schedules and real fuel prices. It's not guaranteed, no technology is, but it's grounded in verified chemistry and Tesla's existing maintenance record. The Unboxed manufacturing helps you keep your independence by reducing the number of reasons you'd ever need to visit a service center. The less your vehicle depends on a dealership to stay operational, the more control you have over your own schedule, your own routine, and your own life. The vision-only safety system and simplified interface help you keep your dignity, because dignity at 67 or 72 or 78 looks like getting in a car that you understand, that responds when you tell it to, that doesn't beep at you 17 times on a 10-minute grocery run, and that gets you where you're going without making you feel like the technology is smarter than you are. Technology should serve you, not the other way around. Now, 5 groups of people who should think carefully before committing, because I told you I'd give you the full picture. If you don't have a place to charge at home, a garage, a carport, a dedicated outlet, this equation changes significantly. Public charging works, but it adds friction that changes the daily experience of ownership. If home charging isn't possible in your situation, have that conversation first before anything else. If you regularly drive 150 miles or more in a day, in cold weather climates, Minnesota, Wisconsin, upstate New York, the real-world winter range on a 53 kilowatt-hour LFP pack could drop to 160 to 180 miles. That's workable with planning, but it's not the same as the EPA number. If your primary concern is resale value in the first 3 years, early production Model 2 units carry more uncertainty than later production runs. Every new Tesla platform has a quality ramp period. The Model 3 proved this. If resale is a priority, waiting for the second model year is a reasonable strategy. If you frequently haul significant cargo weight or regularly tow, the Model 2's towing capacity is projected at around 2,500 pounds with the optional package. That covers a small boat trailer or a utility trailer. It does not cover a fifth wheel or a substantial camper setup. And if you need a vehicle right now, today, because your current car just gave you a $3,400 estimate, this car doesn't exist yet in showrooms. Don't let urgency drive you into a scam. Tesla makes no pre-production reservations through third-party sites. When the Model 2 opens for orders, it will be on Tesla's official website only, not through email, not through a text message, not through a YouTube channel. Official website only.
Here's what I want you to walk away with. 3 engineering decisions. Pin battery that could make this the last car you ever buy. Unboxed manufacturing that removes decades of failure points, with 1 repair cost trade-off you need to understand. And vision-only safety and real physical controls that give you technology that works for you instead of demanding you adapt to it. This channel doesn't exist to sell you a car. It doesn't exist to make you excited about Elon Musk. It exists because there are decisions coming in your retirement years about your vehicle, your home, your connection to the world, where getting it wrong isn't just inconvenient, it's life-altering. And you deserve straight information before you make those calls. If this video gave you something useful, something you'll actually think about before your next decision, I have one simple ask. Hit the subscribe button right now and turn on notifications, because the next video in this series is one of the most important ones I'm going to make, and I don't want you to miss it. Next week, we're running the numbers on 3 price scenarios for the Model 2, not the $12,749 you've been hearing, because that's the production cost target, not the sticker price. We're looking at $18,000, $22,000, and $28,000, and asking the question nobody else is asking: at which price does this car stop making financial sense for someone on Social Security? I'm going to show you the exact break-even math year by year, including insurance, charging, depreciation, and what happens if the battery needs service in year 9. Before you go, I have one question for you, and I genuinely want to know your answer. Of the 3 shifts we covered today, the battery longevity, the simplified manufacturing, or the vision safety system and button interface, which one matters most to you personally? Type battery if long-term cost and no surprise repair bills is your number 1. Type build if you care most about the car being simpler, more durable, easier to own. Type buttons if what matters most is a car that doesn't make you feel like you need a technology degree to adjust the air conditioning. I read every single comment. Your answers shape what this series covers next. Drive safe, make informed decisions, and never let anyone, not a dealership, not a YouTube channel, not a well-dressed salesman at a community event, pressure you into a financial decision you're not ready to make. I'll see you next Tuesday.